So, as Hamburglar said, I'm from the University of Edinburgh, and one of the great things of working for a university is it gives me the chance to have an independent opinion. And I have made comments at some of these conferences before, which have made me popular with some people and unpopular with other people. But my background is primarily as a scientist, as a fire scientist. I didn't come to the subject of tunnel fires from the tunnel end of things. I came from the fire end of things, and not even from the smoke end of things, but from the fire end of things. So that's very much the focus that I'll be looking at over the next 25 minutes or so, is how do fires behave in tunnels, and how do the systems we put in tunnels mitigate the fires themselves and the effects of fires. And I'll try and make that clear up front. Sometimes when we talk about mitigation, we mean mitigating the fire itself, which will involve reducing in some way the fire. And sometimes we may just be talking about the effects of fire, so maybe in terms of protection. But we'll get into those in a minute. So, a quick overview of what I'm going to be saying over the next few minutes. First of all, I have a picture of me with a question mark on my face. Who am I, and why am I standing here telling you about mitigation of tunnel fires? Then I'd like to look at fire itself and say a few things about, very general terms, about how fire behaves and how fire behaves in the tunnel environment. Then I actually want to talk about some dictionary definitions of what certain words actually mean, because one of the opinions I will be expressing is that the words we use are not the same words as the rest of the world uses. They use some of the words with different meanings, and we use some of the words with different meanings, and I think we need to be clear about what we mean. If we describe something as a suppression system, I think it should in some way suppress a fire. If it doesn't suppress a fire, we shouldn't call it a suppression system. And maybe I'll make myself even more unpopular when I get to that bit later on. Then I'd like to talk about the systems themselves, and I'll briefly touch on 7 different types of mitigation systems and how they affect the fire. Then I'll focus in on water sprays and tell you why water is such an excellent mitigation system. And then I will make some brief comments towards the end about the future. And that image there is simply supposed to represent the tunnel of the future. Where are we going? So we'll kind of start with where we are, and then where are we going? What do we do in the future? So, as Hamburglar said, I've been working in the field of tunnel fire safety for 14 years now. I started working at Heriot University, it's a university just outside Edinburgh, in 1998 on what I thought was a little project on fires in tunnels. I knew I was going to be spending 2 years doing it. I thought it was quite a niche market. I did some research for a few months. I put a paper into a conference that was to be held in France in May in 1999. And I was fully expecting to turn up at that conference and see a room of maybe 50 people who were vaguely interested in the subject. And of course, in between my paper being accepted and the date of the actual conference, this happened, the Mont Blanc tunnel fire. And that turned the gathering in France from a small, possibly inconsequential affair into about the same number of people as we have seated here, some of whom were holding up recording equipment, recording what I had to say, because what I had to say was why HGV fires can get so large in tunnels. Later on that year, though, it was my first interaction with we'll call it the suppression debate. I went to a conference in Basel at the end of 1999 on long road and rail tunnels. Can I have a show of hands? Was anyone else in the room actually in Basel back then? 1, 2, 3, 4, 5. Oh, a very small number of people here were there. I have to say, the debate at this conference shocked me. There was, at the time, a lot of discussion about the Beta route, which is a freight-only rail service through the Netherlands that goes through a number of tunnels along its length. And they were in the process of designing that and talking about installing sprinkler systems in the tunnel sections of that freight railway. And this provoked a heated debate. To the extent that after one of the Beta route presentations, one of the people that stood up and asked the question expressed the opinion that the suppression system in the beta route, if activated on a tunnel fire, would kill the driver. You laugh, but about half of the people at that conference nodded in agreement. At the time, at the end of the 90s, that was the official stance. A suppression system was not a life safety device and could not be used as a life safety device because there were reasons why it would cause harm to people. I would say that was the industry opinion at the time. PRC, NFPA both made statements to that effect. You shall not use a sprinkler system as a life safety device. Things have changed in the past 12, 13 years since then. One of the things that I was involved in that I don't know if it's in any way influenced the change was the Hamburglar Tunnel fire safety, but I'm sure many of you are familiar with that book, and I hope many of you own that book. Thank you very much for buying. When I came to edit that, we started planning that book in 2001, and one of the issues raised was, should we have a chapter on suppression? And the overwhelming response we got from talking to a few people was, it's a non-issue. No, you can put in a little bit, but in the end, the suppression part was part of one page in the protection chapter. 5 years later, when we came to the second edition, things had completely changed. The next time I interacted with the suppression debate was a few years after this, when I went to one of the previous conferences in this conference series in Stockholm, a very lovely city, and I had the chance to give 2 talks at that conference, both of which had implications for suppression systems. Those of you that were there may remember these graphs that made me somewhat notorious. This was one of the graphs I presented, which was some calculations we'd done showing what would happen to water mist droplets if there was forced longitudinal airflow. And as you can see, the smallest water mist droplets get carried a long way down the tunnel, according to our calculations, and perhaps don't interact with the fire in the fire zone. If we've got a 50-metre zone of tunnel here, only the larger droplets possibly have the chance to interact with things at ground level. There has been much debate in this, and I'll come back to it later. But by the time, as I say, when I came round to the second edition of the Tunnel Fire Safety Handbook, we have a full chapter in there now, looking at the pros and cons of water-based suppression systems in tunnels. And Yaju, who's sitting at the back there, and I wrote that chapter. And there's an awful lot now to say on the subject of suppression. And I unfortunately don't have time to go into too much detail. But I still have questions. A lot of work has been done over the past decade in the Upton project and the Solid project and things that you'll no doubt hear an awful lot about over the next few days. But I still have a lot of questions, to the extent that I actually went to some of these conferences are in great locations. Last year I got the chance to go to Nice to speak at a tunnel fire conference. And it was like that. It was raining when I left Edinburgh. It was like that for 3 days in Nice. I went back to Edinburgh, it was raining. But I had a paper in there, which is very simply called Water Mist Systems in Tunnels, Some Unanswered Questions. And at that time I had 9 questions, which I didn't feel the research had adequately investigated, and I'll come back to some of them later. I have to say one of those questions I think has now been reasonably answered, but that means there's still 8 unanswered questions as to, do these systems actually work in reality in tunnels for fire? And then, also last summer, I had the opportunity to go to a workshop run by the Solid, part of the Solid 2 project, where I actually got, that's a photo of me, standing in water mist. I think that's Xavier behind me and Stefan Kratzmeyer from AFAB in front of us. We've just been walking through water mist right up to about maybe 4 metres away from a 15 megawatt fire. That was quite some experience. And whatever else I say for the rest of the talk, I remember that experience of standing very close to a fire and realising the fire brigade can get that close to the fire. The fire brigade can get right up there and put the fire out. I have no doubts about that. My main doubt is that a suppression system, is that a protection system is that a mitigation system or is that a firefighting system? And I think we should be careful about what words we use, because clearly it wasn't a firefighting system because the fire brigade had to go in and do the fighting. One of the dangers you have of when you invite someone from a university to speak at a conference like this is you're in danger of getting a lecture. And I almost felt like giving you a lecture called Fire Science 101 at this point. I think I even put that heading in the paper in the proceedings. Because all fire safety lectures or lecture series start with a fire triangle. It's one of the most basic concepts, and I'm sure many of you have come across the concept of the fire triangle before. To have fire, you need three things. You need something to burn, the fuel. You need some oxygen, obviously, and you need some heat. Give it an ignition source, you have a fire. If those three things remain, and in significant quantities, the fire continues. If you take one of them away, if you take the oxygen away, the fire goes out. If you take the heat away, the fire goes out. If you take the fuel away, the fire goes out. And to some extent, if you can control but not remove one of those aspects, you can control the fire. And I had thought about using the fire triangle to explain mitigation in tunnel fires, and I found I couldn't do it. And I felt what I really needed was basically a couple of extra sides, something a bit more than a triangle. So I've gone for a pentagon, and I'll spend a minute or two explaining what I mean by this pentagon. It's not exactly the same as the triangle, because if you remove the tunnel, you don't necessarily remove the fire. If you remove the smoke, you don't remove the fire. It's not quite the same as the triangle. But I would say that all mitigation systems act on a fire in a tunnel involving one of these five aspects of the tunnel. Or of the situation. For a start, there is a feedback loop with the fuel. There is heat from the fire going to the fuel, which releases gaseous fuel back into the fire, and there's a feedback loop going there. If you can interrupt those processes, you can mitigate the fire and mitigate the effects of the fire. Similarly, we need air coming in. If you can break that process, you can influence the fire. And then we've got heat losses. Heat goes a number of places. It goes to potential fuel, and if you can prevent it going to potential fuel, you prevent fire spread. It goes to the tunnel, and if it's hot enough, it damages the tunnel. It goes to smoke. We also have mass transfer going to the smoke. And again, if we can interact with any of these interchanges using some form of mitigation system, we can influence the fire. Because two of these at the top are a two-way process. Once the thing gets hot, the hot smoke and the hot tunnel start interacting with the fire. And again, if we can break those or interfere with those processes, we can mitigate the fire and mitigate the effects of fire. So, what does the dictionary say? The dictionary says mitigation is simply to lessen and force or intensity. I think that's the general term for the systems that we put in our tunnels. Mitigation systems. Suppression is a more precise word. I checked, this is from Webster's dictionary. There's a number of different definitions I found, but those are the three main ones that relate to fires. I would say that the lowest common denominator of them, of suppression, is to hold in check. So if we suppress a fire, that doesn't mean we have to reduce it, but if we can hold it in check, that's suppression. That's what the world understands by suppression. That's not necessarily what we have used the word suppression to mean. Control is another word, which also means, middle definition there, to hold in check. In fact, I would argue that suppression and control are the same thing when we're talking about tunnel fires. And it slightly confuses me that NFPA means two different things by those two words when the dictionary says the same thing for those two different words. And I think we should be very careful about our terminology. Protection is a much simpler concept. We understand it's to defend from guard or attack, and firefighting is the activity directed at limiting the fire and extinguishing it. And I'll come back to some of those words in a moment. But what are the systems that we put in our tunnels? I did a short survey of what have been suggested for tunnels and what have gone for tunnels. Obviously, ventilation systems have been there for well over 100 years. They can mitigate the effects of fire. Sprinkler systems have been installed in some tunnels since the 60s, and certainly in Japan, and are now increasing in other parts of the world. I couldn't find a picture of a sprinkler system with additives in a tunnel. So here's a picture of a man holding a water spray with foam in it. But that's the next step up, like I mentioned in the beta route in the Netherlands. Water mist systems, becoming increasingly popular in Europe, certainly. High expansion foam systems. I know of one tunnel currently under construction that is installing a high expansion foam system. And I'm not going to say much about that today, but it's in the paper, so I urge you to look at that. Systems which introduce an inert gas into the tunnel to try and restrict the flow of oxygen. And systems, again, I don't know of any system that actually uses this in an emergency, but I have heard it proposed that if you have some sort of system that can compartment the tunnel, you can contain the fire to a certain locality, preventing air from getting to it and preventing it from spreading. So compartmentation is the seventh system. And for each of them, I'll use the same pentagon, and here I have a sliding scale of the effects that the system has on each of the different interchanges around the pentagon. So for example, ventilation, when we switch the ventilation on, if we blow at the fire, we're introducing more air to the fire. So we're actually enhancing this, which probably has a knock-on effect of increasing some of the other effects. But will have another effect of diminishing certain of the other effects. So the heat transfer to the tunnel and to the smoke is probably diminished, such that, well, a ventilation system is not necessarily a way of mitigating the fire itself. You can certainly mitigate the effects of fire, the smoke, the heat, from those on the upstream side of the tunnel. The sprinkler system or deluge system doesn't really, I don't think, change the air coming in, but does have an influence, and probably a positive influence, on all the other aspects. We're reducing heat transfer by introducing a cooling mechanism. We're probably introducing some water vapour, which dilutes things a bit. The smoke is cooled, the tunnel structure is cooled, potential fuel is cooled. Hopefully this feedback loop for the involved fuel is also considerably reduced. When you put additives in there, more or less the same, apart from what you achieve is a better control over the potential fuel, because you're smothering the potential fuel in foam, and hopefully that will further prevent fire spread to potential fuel. When we go to water mist, we get a general diminishing of everything, including the air coming in, because as the water mist interacts with the hot surfaces, it produces an awful lot of vapour, which dilutes the incoming air. This is all from the perspective of the fire, of course. The fire sees less air. The effects of the fire are blocked. Some of the heat transfer interchanges are diminished, not broken entirely, but are certainly reduced by water mist. When we go to a high expansion foam system, that is designed simply to flood the entire space, basically blocks everything. On one level, that's an excellent solution. On another level that we'll come to in a minute, perhaps not. But it blocks the incoming air, puts the fire out. It blocks the potential fuel, blocks everything. Gas-based systems tend to act on the air coming in, so we're reducing the oxygen content. I go into more detail in gas-based systems in the paper. I don't really have time to say too much about them up the front, but they're acting on the air coming in, which has a knock-on effect of diminishing everything else and hopefully extinguishing the fire. And finally, compartmentation systems. If you can effectively introduce compartmentation into your tunnel in some way, you're blocking the air coming in, and you're separating the fire from the potential fuel that's further down the tunnel, and probably diminishing everything else as a result until the fire starves out, runs out of air where it is, and self-extinguishes. All of that has been from the point of view of the fire, not with the point of view of the smoke, and the other main implication, not from the point of view of egress. The thing I haven't mentioned so far is that there has to be some interaction between these systems and the people that are escaping. If you want to activate a system early, you have to activate it when people are there. And that is a real problem if you're trying to flood the space with high expansion foam. That's a real problem if you're trying to flood the space with an inert gas, because people need air to breathe, just as the fire needs air to survive. So I would say Some of those systems are fully compatible with egress, and I would say the sprinkler deluge system, we've seen from the Burnley Tunnel fire how well that worked in practice. People got out, 400 people escaped, no problem. Ventilation system is designed to blow the smoke away to give people a smoke-free egress path. Inert gas systems, high expansion foam, probably incompatible with egress, and so if you have systems like that, you have to think, how do you get the people, even if it's only one driver, how do you get those people out? And in the middle, the debate's still going on. I have to say, from my experience of walking through Watermist last year, I'm quite confident I could see 10 metres, I could see one side of the tunnel to the other when the Watermist system was active. I am in favour of Watermist systems being activated early while people are still escaping. Other people are not. I was at a sprinkler conference in the UK 2 weeks ago when one of the speakers basically gave a rant rather than a presentation explaining his experience of Watermist in a building, admittedly, where he became completely disoriented and couldn't find his way out and had to be rescued in a demonstration test when it was only a waste paper basket on fire. And so the debate is still going on. Maybe it's not going on in this room, it is going on in some sectors of the sprinkler industry. In compartmentation, I wasn't quite sure where to put that, but I put it in the middle for balance. But again, if you're compartmenting the tunnel, what about the people that are inside the compartment that the fire is in? I'd like to talk briefly about water, because water is a marvellous thing. Water is a unique chemical, and the more I looked into the firefighting properties of water, the more impressed I became. Water, by all rights, shouldn't be liquid at room temperature, but it is. Water, by all rights, shouldn't take as much energy to evaporate as it does. And it's just the polarity of that little molecule gives it an immense, great effect for firefighting. Because in most tunnels and most climates in the world, it's liquid. We can get liquid at the fire. It takes an awful lot of energy to evaporate that, so we're taking an awful lot of energy out of the environment. In fact, 1 kilogram of water takes about 2.5 megajoules of energy to evaporate that. So if you have a 2.5 megawatt fire, if you can get 1 kilogram of water per second on that fire, you're putting enough water there to take all the heat out of that fire. The problem is not the water, the problem is getting the water to the fire. And we'll come back to that in a moment. The ongoing debate is good old-fashioned sprinklers against water mist, which is better. A few brief comments here. Sprinklers are great at soaking surfaces and preventing fire spread by cooling everything down. Water mist is great at interacting with fires. The water mist drops are so small that they can actually interact with flames at the flame level. The big drops of the sprinkler don't. But the question is, which do you want? Do you want to prevent fire spread and cool everything down? Do you want to actually interfere with the fire? There are different circumstances, I believe, when one's more appropriate than the other. There's also the question that I probably don't have time to go into again, but you can pick my brain about it afterwards, of where do the drops go? The larger the drop, the less influenced by water it is. I don't think there's any disagreement on that. Perhaps we're not dealing with 100 metres of transport distance for a 90 micron drop, but for 3 metres a second airflow, which is that picture there. But the larger it is, the less influenced by ventilation it is. And tunnels are windy and well-ventilated environments. And also, I couldn't find a good picture there, so the picture there is just to give an impression of protection. How much thermal protection do these systems give? Water is excellent at blocking radiant heat. Water is brilliant at protecting structures from the influences of fire. And there was a direct comparison done as part of the Solid project between water spray and water mist. And they compared the effects, and for most of the duration of the fire there was good performance, good protection by both systems. I have to say, towards the end of the fire test, water mist slightly performed better, because one of the aspects of the large drops is they tend to fall away from the ceiling and heat tends to rise. But on the whole, water is good at blocking radiant heat. So a few questions of where are we now in closing. Can water spray systems, I'm being generic here, mitigate the effects of fires in tunnels? Absolutely yes. here's where I make myself unpopular with some people. Can water spray systems reliably suppress cargo fires? I don't think we have evidence to say yes. In fact, I think we have evidence to say, we know they can suppress open pool fires, we know they can suppress a pile of wooden pallets. As soon as you put a tarpaulin over it, things change. As soon as you put plastics in there, things change, and we simply do not have the data set to be able to say yes to that question. And that is my plea to those that are involved in testing and setting up regulatory tests. Don't just test it in wooden pallets. When was the last time a lorry load of wooden pallets went on fire in a tunnel? If you look back at the real incidents that happened, Mont Blanc was a refrigerated truck with flour and I'll be 2 more minutes. With flour and oil in it. That was nothing like a pile of wooden pallets. In the St. Gotthard tunnel fire instance, there was a lorry load of tyres. Nothing like a wooden pallet. And so I think we need to invest some time and effort into looking at different cargoes and how the systems that are being proposed actually interact with different types of fire. But can water spray systems reliably protect tunnel structures? Yes. What we're dealing with is a protection system, not a suppression system. That's my opinion. And can water spray systems reliably prevent fire spread in tunnels? Most of the time, yes. But there have been fire tests carried out in tunnels with real vehicles where the fire spread while the water mist system was active. Again, look at the paper. I don't want to go into any more details just now. But we've seen it at least once. That means it can happen. That means we can't be complicit. I've forgotten the word. We can't just rest on our laurels and think they work all the time. And so where do we go from here? I think we need to be careful about classification. If a system is demonstrated to fight a fire, it should be a firefighting system. If a system is demonstrated to suppress a fire, we should call it a suppression system. If it's able to protect the structure, we should call it a protection system. And if it's only able to mitigate in some way, we should call it a mitigation system. But I don't think a fixed firefighting system is the generic term that covers all these aspects. And yet that's the terminology we seem to have come to. So into the future, I think we need to agree on classification. We need to establish a set of realistic standard tests that test more than wooden pallets. And I think we still need to look into how we get the water to the fire. Because I think we can improve deployment just above the system of having nozzles at ceiling level. But that is a matter for a discussion another day. So thank you very much for your attention.